we're going to look now at exponential notation. The idea is we want to multiply the same number repeatedly. We want to do something like 2 times 2 times 2 times 2 times 2 times 2 several times. And we want a way to abbreviate this so that we can write it a little bit simpler. And this is the basic idea of exponents. We're going to let a be any real number, and n needs to be a positive integer, something like 1, 2, 3, 4, 5, etc. So a to the nth power, a to the n, is equal to a, etc., n times. So this number at the exponent of a tells us how many times we multiply a by itself. We call a the base and n the exponent. So let's look at evaluating some of these. The first one I want to look at is 1/3 to the 4th power. So this means I need to multiply 1/3 by itself 4 times. So I have 1/3 times 1/3 times 1/3 times 1/3. And when I multiply all those out, I get 1/81. The next one I want to look at, -2 to the 4th. And when we're dealing with exponents, we need to really be careful of parentheses. This means -2 times -2 times -2 times -2, which gives me positive 16. On the other hand, this -2 to the 4th is different. Like I said, we really need to be careful of parentheses. This one means -2 times 2 times 2 times 2. So when we have parentheses, we include the negative, but when we don't have parentheses, it means raise that number to the power and then put on the negative. So here we get -16. There are several rules for working with exponents, and we're going to start with one of the most basic ones, the multiplication rule. Let's consider 3 to the 5th times 3 to the 4th. 3 to the 5th means I multiply 3 by itself 5 times. 3 to the 4th, I multiply 3 by itself 4 times. So I've just expanded each of these. And if we count these up, this is multiplying 3 by itself 9 times. So this would be the same as 3 to the 9th. Which we should notice is just 3 to the 5 plus 4. And this is the basic idea of the multiplication rule. The general multiplication rule says that a to the m times a to the n is equal to a to the m plus n. So if we're multiplying two exponents with the same base, then we just add the exponents. Right now with my exponents, the exponent needs to be a positive integer, but I want to be able to expand that to include any integer, not just the positives. So let's see what happens with 0 exponents. Let's consider 3 to the 0 times 3 to the 4. Using my multiplication rule, that gives me 3 to the 0 plus 4. That tells me that 3 to the 0 times 3 to the 4 is just equal to 3 to the 4. And there's only one way that can be true. And that's if 3 to the 0 is equal to 1. That way we have 1 times 3 to the 4th is equal to 3 to the 4th. And in general, this is going to be true. Provided the value of a is not equal to 0, then a to the 0 is equal to 1. So any non-zero number raised to the 0 power is just going to be 1. Now that we've expanded the idea of exponents to 0, let's look at what happens with negatives. This time I'm going to look at 3 to the 4 times 3 to the negative 4. Using my multiplication rule, that gives me 3 to the 4 plus negative 4. Simplifying gives me 3 to the 4 times 3 to the negative 4 is equal to 3 to the 0. We just discussed how anything to the 0 power is 1, so now I have 3 to the 4 times 3 to the negative 4 is equal to 1. And dividing both sides by 3 to the 4th gives me that 3 to the negative 4 is equal to 1 over 3 to the 4th. In general, if a is not equal to 0, then we have that a to the negative n is equal to 1 over a to the n. So essentially, I can get rid of a negative in an exponent if I move it to the bottom of a fraction. Let's look at some examples of this. The first one I want to look at is 3/8 to the 0 power. we know that anything raised to the 0 power is 1. So this would just be equal to 1. If I have x to the negative 2, we tend to not like writing exponents as negatives, so we need to move this to the bottom of the fraction. And when we do, we get 1 over x squared. Negative 3 to the negative 4, once again, negative exponents, we want to move to the bottom of a fraction. I then get 1 over negative 3 to the 4th power. And negative 3 to the 4th power is 81. So I get 1 over 81.